All right. Part 1. You need to get the class on time. Part 1. Easy. That's review. That's what your quiz was over. Part 1. Find the domain. What are the 2 things that we have to remember when we're talking about domain? Denominator cannot be 0. And what's the other thing?
Anything under a radical.
If you're under a radical, has to be greater than or equal to 0. If you remember those 2 things, then you can't go wrong. So I look at problem number 1, or A, problem A. What can you tell me? X minus 2 cannot be 0, which means X cannot be 2. But also, X plus 1 has to be bigger than or equal to 0, which means X is bigger than or equal to -1. So this is a 2-part answer. There's a fraction, so I have to take care of the denominator. And there's a radical, so I have to take care of that. So this is a 2-part answer. This is what you write down. Your domain is everything bigger than or equal to -1 except 2. All right, look at B. All real numbers. Somebody said all real numbers, and whoever said that is exactly right. Why is the domain all real numbers? Is there a fraction?
No.
So you don't have to worry about rule number 1. There's no fraction. Is there a radical?
No.
So you don't have to worry about rule number 2. So we're not worried about anything. Anything goes. All real numbers. Look at C. Is there a fraction? In C, is there a fraction? No. So I don't need to worry about rule number 1. Is there a radical though?
Yes.
Yes. So I need to worry about 2x minus 5 has to be bigger than or equal to 0, which means x has to be bigger than or equal to 5/2.
So for B, since there was neither, you just said anything?
All real numbers. The domain is all real numbers for B. For C, the domain is x is greater than or equal to 5/2. Okay? Now, number 2. I want you to figure out and graph the horizontal asymptotes, the vertical asymptotes, and the holes. Now, in order to do that, vertical asymptotes are located where the denominator is 0. So whatever makes the denominator 0 is where you put an asymptote. Because what do we know about fractions? The denominator can never equal 0. So you're going to mark that in your picture with a vertical line. That says to me, oops, that's off limits. And it's going to be off limits because it would make the denominator 0. So when I look at problem number 1, and by the way, I'm in function mode from last period, so I used f of x. On the paper I wrote y. Does it make a difference? No. F of x and y are the same thing, right? They're interchangeable. Now, what number would make this denominator 0? What would you put in that would make the denominator 0? -5. So you're going to draw a vertical asymptote at x equals -5. That's what you're going to draw on your paper. And you're going to write x equals -5. You're going to draw just what Mrs. Ford drew. Okay. Why is there a vertical asymptote at -5? Because what happens if you try to put -5 into your fraction? You get a 0 in the bottom, and that is not allowed. So we indicate that. Don't you think about putting a point here. No, this is off limits. Now the horizontal asymptote, just try to hang with me. This is going to take a little bit of time to get used to, but it's easy. The horizontal asymptote is found by looking at the x's in the problem. Just the x's. Don't look at this part. So if I cross all that off and look at just the x part, my equation says y equals, this is y equals what? What would that reduce to? 2. Your horizontal asymptote is at y equals 2. If the problem had been, you don't need to write this down, but just look, if the problem had been 5x plus 4 over 2x minus 3, the horizontal asymptote would have been at y equals 5/2. If you had y equals 8x minus 7 over 3x plus 1, that horizontal asymptote would have been at y equals 8/3. Now, it could get a little trickier than that, and we'll cover that, but for now.
You just use the denominator?
Yep. Yep. The verticals come only from the denominator. All right, so let's look at the next one, because this is harder, and I know we haven't practiced much. We are going to try to hang tough here for a minute. Any ideas, just looking at the problem, which is a much bigger problem, any ideas how we would even start?
Set the denominator to 0.
Even before we do that, factor. Let's look at our problem and let's notice that it breaks down, doesn't it? How does the top factor? 5 and 1, plus 5 or minus 5? Minus 5 plus 1, good. How does the bottom factor? Plus 1 minus 1? Now your little heart should be going pitter-patter, because what do you notice? You can cancel. Oh boy. That's big. Before I talk about what that cancellation means, let's get our asymptotes in here. Look at your simplified problem. Look at your reduced problem down here. Okay, right here, this is your new problem. Where is the vertical asymptote?
1.
What makes the denominator 0? 1. So you're going to have a vertical asymptote where x equals 1. Where do verticals come from? The denominator equals 0. Now, let's look at just the x's in our equation. Where would the horizontal asymptote be?
1.
Y equals 1. X over x, reduce x over x, it's 1, right? Now, notice the directions, talk about horizontal and vertical asymptotes, and holes. The hole happens where you cancel. So we canceled out x plus 1. If you cancel out anything, you're going to have a hole. The hole is simply an open point in the picture. It's a point. Does anybody want to guess what the x-coordinate of the point is?
1.
Not 1,
-1.
-1. Have you noticed a recurring theme? When we have parentheses, don't we usually use the opposite of what's in the parentheses? So like you have x minus 1, where did we put the asymptote? at 1. We crossed out x plus 1, so the whole is going to be at negative 1. If we would have crossed out x minus 3, then the whole would have been at 3. Now, the whole is a point. You know the x part because it comes right from whatever you canceled. How do you think we could get the y part? How do I get y? I don't want to plug in 0, I want to plug in negative 1. If I want to know what the y coordinate is, don't I plug in the x coordinate? So if I plug in negative 1, I will have this, which is what? I'm putting in negative 1 for my x's. So what do I get? Negative 6 over negative 3, which is 2. So I have an open circle in my picture at negative 1, comma 2.
That's only if you're factoring, right?
Only if you can cancel.
Okay.
We point, like, show that on the graph.
Yep.
Like, graph it.
Yep, just that point. Your picture should look just like mine. Now, as we go farther, we'll fill in the rest of the picture, but these are what are called the discontinuities. These are the things that break up the picture. The asymptotes split the paper into 2, basically, or 4, if you look at both asymptotes. And that breaks, that's a little break in the curve. So back up one step. How did I know I needed a hole? The first example I did didn't have a hole. How did I know this problem was going to have a hole? Something canceled. Okay, so step 1, if you have a cancellation, you're going to have a hole. Now, where did the x coordinate come from for the hole?
What you canceled.
The opposite of the factor that I canceled, right? So when I canceled out x plus 1, that meant I was going to have a hole at negative 1. Where did the y coordinate come from? I plugged negative 1 in for the x's. Oh, where does 2 come from? That hole should be at 3. Sorry about that. I think I was thinking ahead, thinking it was going to be 2, so I wrote 2. So it's negative 1 minus 5, negative 1 minus 1. That's where the hole is. Sorry about that. Okay, so back up. Make sure you made that change on your paper. I put in negative 1, so I have negative 1 minus 5, negative 1 minus 1. I can't believe you let me get away with that. Nobody said anything. Negative 6 over negative 2. All right, let's try the next one. Let's look at C. How do you want to start problem C? They're factor. Yep, always factor if you can. Top doesn't factor. How does the bottom factor?
X plus 2x minus 6.
Oh, wait a minute. Will this picture have any holes?
No.
No holes. How do I know there's no holes? Because nothing cancels. I can factor, but nothing cancels.
Plus 4.
Okay.
Couldn't you do it where it's x plus 1 and then x minus 4? So it does.
The denominator?
Yeah.
Okay, that would give me x squared, and it would give me minus 4. But in the middle, it's going to give me minus 4x plus x when I FOIL, which is negative 3x. I don't have that in my problem. You see what I'm saying? Any way you factor, you have to be able to FOIL it back together and get your problem, and that does not work. Okay? All right. I know this is a lot of information. Just got to try to hang in there. Vertical asymptotes, this problem has two. There are two vertical asymptotes. Where are they?
-1 and +2.
Watch it now. Where do verticals come from? The denominator. So where are my vertical asymptotes? -2, x equals -2, and x equals +2. All right? Now, I want you to put your pencils down for a minute. I want you just watching and listening for a second. I don't want you writing all these down. It'll just confuse you when you look at your notes later, but I want you to look at this for a second. Now, if I said to you, for this problem right here, where is the horizontal asymptote? You would circle this part of the problem right here and say the horizontal asymptote is where y equals 2/3. And if I said this one, where's the horizontal asymptote, you would circle this part of the problem and say y equals 5/6. Because what I didn't tell you before is when you compare to get your horizontal asymptote, you got to be using the biggest power in the problem. So this one has x's, but I don't use the x's. I only use the x squareds. Now, this becomes problematic in your problem. Because what do you notice about your problem? Jack? The x's aren't the same. And that's a problem. The x's have to be the same. So whatever is missing, what's the highest power in this problem?
Squared.
X squared. The bottom has one, the top doesn't. So if it's missing, you put in a 0 x squared. You fill it in, 0. I got 0 x squared. Now, where is that asymptote going to be? At 0. Because 0 over 1 is 0. So your horizontal asymptote is at y equals 0. Go ahead and write that down. Fill that in on your picture. Your horizontal asymptote is at 0. And why did that happen? Because the powers didn't match, and the big one was in the bottom. So I had to put the 0 in the top, right? And that left me with a fraction with 0 over something, which is always 0. So that's always going to happen. If the power on the bottom is bigger, then you're going to have to put a 0 on top, and that means your asymptote's always going to be at 0. So let me say that again, because it will never change. If the power on the bottom is bigger, your asymptote, your horizontal asymptote is going to be at 0 every time. No holes, we're done. Let's look at the next one. All right, what do you want to do with the next one?
X plus 2x.
The top factors. Uh-oh, what do we notice again about this problem? Nothing cancels, so there won't be any holes. However, there is an asymptote. Where is your vertical asymptote? At x equals -1. Vertical asymptotes come from your denominator. All right, now wait a second. Look back up here. What's the highest power in this problem? X squared. I don't have any in the bottom, so I got to put a 0 x squared down here. Now tell me about that. That's not possible. You can't have a 0 in the bottom. If it's not possible, where is my horizontal asymptote? There isn't one. I'll write the word none. There isn't one. Why did that happen? Because the biggest power was on top, so I had to put my 0 into the bottom, which isn't allowed. So there is no asymptote. So let's back up a minute and recap. If the powers don't match, then you're going to have to put a 0 in, right? So if you have to put the 0 in on top, then the asymptote is 0. But if you have to put the asymptote in on the bottom, or if you have to put the 0 in on the bottom, then there is no asymptote. Okay? All right, let's get out our note sheets then.